Yes. Is there no post-lab on yours thing?
No, there is on the back, but it only goes to 6.
So how many is in the book? 10. You probably ought to do the 10. I probably just didn't get you the next page. Yes, on your lab, please go to 10 on your post-lab questions that are in the lab book. All right, so chapter 5. If it were me, this chapter would be split into like 3 different chapters. So there's a lot of material in this chapter. So probably even more important that as we do each day, you grab down most important stuff of each day so you have something for your 3x5 card. Some of it's really easy. Some of it kids have problems with. So if you'll stay with me, I think we'll be okay. So it's all about chemical reactions, but it's not just chemical reactions. They go into a lot more things. So the introduction to basically a chemical reaction is we already did the chemical physical change lab. So we basically know what's a chemical, what's a physical change. Who can tell me the difference? We did that lab. What's the difference between a chemical and a physical change?
Well, physical change alters the physical state.
But we can put it back, right? Or it's just the same stuff and cut into small things. Right. For the most part, we can't put it back. Sometimes chemical change can be reversed, but it's harder. Okay. Physical change, I can change it by changing the temperature, making it solid, making it liquid. Okay. This is interesting. I don't know what's going on with my screen, but it's sort of fuzzy. Okay, a physical change alters the physical state of substance without changing its composition. So an easy way to think of it is ice. Ice, as it melts, becomes water, which it lets the water molecules move around a little better. And then if we then heat it even more, it becomes steam. It's still water. I still can condense it down. I can still freeze it. It's still water. Okay? A chemical change is a chemical reaction. It converts one substance like logs through a fire to ash. So it changes something. I get something new. Okay? It breaks bonds of the reactants and forms new bonds, making a new product. So, for instance, a tree was mostly cellulose and structure there. As I burned it, it turned to ash, which is carbon dioxide, and some other chemicals mixed in there. Okay, so you're breaking bonds in the reactants and remaking them for the products. Is the screen shifting for anybody but me? It's like a little, yeah, okay. Wondered if it was just me or if that was my other monitor going down. One monitor went down earlier this week. Okay, we okay to move forward? All right, moving forward. So writing chemical equations, a chemical equation is sort of a shorthand. Our reactants are on the left, our products are on the right. The coefficients tell me how many of each I need. So for this reaction here, CH4, which is methane, I need 2 oxygens to go with the methane to be able to make carbon dioxide and water on the other side. So again, I started with something, but I made it into something else by changing the bonds up. Reactants on the left, products on the right. Okay.
Hey, Ms. Howell?
Yes.
I had a question.
Yes.
So when our semester ends, is that the end of the Weaver State semester too?
Nope.
When is the Weaver State semester?
The end of the year. For us. So we get the whole year to do what they do in 12 weeks. They do 13 chapters in 12 weeks. Yep. And 12 labs. So we're going a lot slower than they are, and I'm helping you a lot more along. You're not going to college. Okay, so
Wait, so when does the term end?
the end of the term is January 10th, I think. Okay, so the law of conservation of mass basically says you can't create or destroy matter. It has to just change what it is to something else. Coefficients we use to balance the equation. I showed you that on the last equation. And a balanced equation has the same number of atoms of each element on each side. So I can't change the number of carbons I have on one side to the other side. They have to balance. I can't just make one disappear or make one appear. They have to be the same on both sides of the equation. Okay, going forward. Girls, make sure you're paying attention, please. Okay, so in the conservation of matter, what do we have in the reactants? We have reactants on the right, our left, and products on the right. On the left, we have one carbon atom. If we look on the right, we also have one carbon atom. If we look on the left, we have 4 hydrogen atoms, but on the right, we only have 2. You see that? So we need to change that to 4. How do we do that? Well, I need to add another water. Okay? I haven't talked about the oxygens yet. I've just talked about hydrogens and carbons so far. Then I go to my oxygens on this side. I have 2. On the oxygens on the other side, I have 4. So now I have to come back and say, I need 4 oxygens on this side. So I need another set of diatomic oxygen. That's how we balance things. It has to have the same number of atoms on one side that it does on the other side. Okay? As we go on, see how the 2 went in front of here? We're also going to put a 2 in front of the oxygen right here so that it will be balanced. So we've got some others. We need to be able to identify the products and the reactants. So we look at this. All you got to remember is the arrow points to the products. Arrow points, products. That means the other side's the reactants. So H2 and Cl2 here are my reactants. The arrow points to my product, which is HCl. On this one, KClO3 or potassium chlorate is my reactant, but oxygen and potassium chloride are my product. On this one, magnesium oxide and carbon are my reactants. Magnesium and carbon monoxide are my products. So on the bottom 2, quickly identify which are the reactants and which are the products. And if you want to use a colored pencil and circle the ones in one color and say these are my reactants and these are my products rather than rewrite them, you're more than welcome to. I put colored pencils out there so you can make things fast and easy. So just color products one color at the top at that thing and just sort of circle them, and that will be a fast way to remember it. But remember, arrow points products. Okay, arrow points to the products. So while you're doing that really quickly, I'm going to come over here and put the magnet in so we don't have people knocking on the door. Okay, so hopefully on the bottom you had the CH4 and oxygen as your reactants and the C2H6 and O2 as your reactants, and then the carbon dioxide and water on both of those were your products. Those are combustion reactions when I get that. Simple combustion. Okay, so equations are said to be blank when matter is conserved. The word we're looking here for is balanced. So I have to balance it in order to conserve matter. This is what I do to balance it. I get a scratch piece of paper and I bump it right up underneath the equation. And then I always leave, like Christmas, the end of the year, ho, ho, ho. Santa says ho, ho. I always leave H and O to the very last, and in that order. H, then O. If I do that, then it balances very quickly. So on this one, I would put H and O right underneath the arrow so I can say which side is which. And then I would go, okay, on this side I have 2 hydrogens. On this side I have 2 hydrogens, balanced. On this side I have 2 oxygens. On this side I have 1 oxygen. That's not balanced. Only thing I can do is put a number in front of it. So if I do 2 waters, that makes 2 oxygens, but that screws up my hydrogens by making it 4. Okay? Then I have to go back to the hydrogen and say, oh, on this side, if I put a 2 in front of that hydrogen, that fixes it to 4. And this is why I use a scratch piece of paper, because then I can just move it to a next little place, and I can do the next one. Okay? So I'll be having scratch paper at the back. I forgot to get it out, but I will get it out for you. So on this one, anytime I have carbon with oxygen, we're just going to do CHO. CHO. And we're going to start again with carbon. Carbon is 1 on this side, and it equals 1 on this side. And sometimes I don't worry about the equals. I just put the numbers. And that's balanced. Hydrogen, we've got 4 on this side, and we've only got 2 on this side. So what do I need to do to fix that? Put a 2 right here, and that changes that to a 4. Okay, then I go to the oxygen. Oxygen has 2 in the reactant side. Now you've got to be careful. If oxygen is in 2 different places, this is how I do it. I say there's 2 plus, this 2 comes through, so I have another 2, giving me a total of 4. Excuse me. Oh, my goodness. Okay, so then I've got to go back and say, okay, I need 4 on this side, so I'm going to put 2 in front of that. That will make it 4, and it's balanced. The reason why I split this and do this plus this is because if I have more on the left side than I do on the right, then I can either times one of them by a number to get to the number I want to. So maybe I don't want to mess with, like if I'd already balanced my carbons, but I hadn't balanced my hydrogens. Maybe I would want to leave this 2 alone, and I needed 2 of these if this side was bigger. Okay, let's do this next one. There's no H or O, so it doesn't really matter which way I go. I'll just do it this way. I have 1 iron and 1 iron. Then I have 2 chlorines and 3 chlorines. I've got to look for a common factor. What's a common factor? 6. So on this side, I need to times this one by 3 to get to 6, but that doesn't mess iron up. On this side, I'm going to have to times the 3 by 2. That's going to mess up my iron and making that a 2. But that's a quick fix by putting a 2 there, and now I've balanced. Okay, would you try the next one? This is going to be a CHO. Actually, this isn't really fair. I should do this one with you. So, on this one, we've got 3 carbons on the left. We've got 1 carbon on the right. So we're going to put a 3 here. Now I have 3. Hydrogens, you got 8. Hydrogens, you got 2. So now what do you need? You need more to fix your hydrogen. So I need how many more? What do I need times that by to get to 8? 4. So that's 8. Now my oxygen, I have 2. I have 4. Plus I have 6. This one actually would work. So a total of 10. So I need 10 here. I put a 5 here. Oftentimes, and we'll get to one, and I'll explain it here in a minute. But oftentimes we have to do a little trick, and I'll give you the trick when we get to one that we need to do that with. Everybody okay so far? Okay. So going forward, we need to know some symbols. And these are the symbols. Okay. An arrow means that reactions happen. A delta means I've applied heat. Yes?
Should we put this on our theory?
If you can't remember it, I would. Okay, a delta means heat, S means solid, L means liquid, G means gas, and AQ means aqueous. That means it's been dissolved in water. So think aqua, if you know Spanish. Aqua, aqueous means dissolved in water. AQ, yes. It is for change, but in chemistry, if it's above the arrow, it means heat. Okay? So I've changed the heat. Okay? So those are the symbols we need. Ready to move on? Okay. So here we've got some. And I am going to bring up just a white piece of paper so I can show you how to do this. First one. Just bring this up real quickly. So this first one is one like I was telling you that you'll need the trick for. That's why I want to sort of show you. And I'll make this my blank piece of paper. We'll make it smaller if I can get it to go down. So I'm just going to put it right there. So here's my blank piece of paper. So underneath it I would do CHO again. C-H-O. I would say, okay, on the left I have 6. On the right I have 1. So I'm going to need to put a 6 here. Now I have 6. On the left I have 6 hydrogens. On the right I have 2. So I'm going to put a 3 there. That makes 6. On the left now I have 2. On the right I have 3 plus 6 times 2 is 12, giving me 15. Here's where the problem comes. I can't times that oxygen by a whole number that will get me to 15, right? So this is the trick here, and it works mostly only with combustion reactions. I can times this just for a second to get it balanced by 15 halves. That would give me 15, right? So I'm going to put 15 halves here, but I can't leave it in a fraction. So, math. How do you get rid of a fraction?
You can divide or do
Times everything by the bottom number, right? So if I times everything by the bottom number, I now have a 2 here. This becomes a 15. This becomes a 6. And this becomes a 12. And I'm done. So rather than try and struggle and go back and try and make it balance, if I use this just for a second, I can get it to balance. Okay, without having to go back and try and figure out what each number is. Okay? So I do have some just regular paper up here. I'm going to just pass around if you need a scratch piece of paper. I like to fold it. So just take one and pass it on. So I like use one edge and then I fold it over and then I use the next edge and then you fold it over and fold it over, fold it over. So here's some scratch paper. Pass some around. I would like you to try these on your own for a few minutes and see where you can get. And I'm going to have you come up and put one up. Thanks. Did you not get one? I'm sorry. Okay, I'll try and have some scratch paper from the copy center back on the back table so you can use that for this. But right now we'll just use this. So what I would do is just turn it like this, and I just put N-A-I-P-B-S-O. N-A, so I just go N-A-I-P-B-S-N-O. And then I go one at a time and try and get them balanced. So just put it right under the arrow. And how many are on this side? So I put 1. How many are on this side? 2. So put a 2. Now I have to make that be 2, so I'll put a 2 in front right here. And then cross that out and make it a 2. Okay, then now I have 2I on this side. And I have how many on this side? Okay, so now I gotta go back and change that 2 to a 4. And when I do that,
can I just erase it?
yeah, that's it. Guys, I always balance with pencil because it's really hard. When I change that to a 4, then that also changes to a 4, right? Now this isn't balanced. So now I got to come back and say, oh, I need how much in front of this? 2. Okay. Now I come back, okay, PB, 1 and 1. S, the 2 comes through, so there's 2 on this side. And there's 2 on this side because that 2 comes through. Now oxygens, 2 times 4 is?
8.
So 8 on that side. 2 times 4 is? You're done. So go ahead and write the answer to this one from up there, right there, so you have it. Okay, Megan, I'm going to have you put up number 2. This pen doesn't work. Try another one. Mia, I'm going to have you put up 3. Whitley, 4. Justin, 5. Riley, 6. Jaylee, 7. It's Jaylee. Yeah, she's there. And Joshua, 8. That's 6. So they only have 1. So now you have to put a 6 in front. 6. Okay, then you go to the hydrogens. 6 and 2. So you put a 3 in front. Then you go to the oxygens. 2 and 3 plus 12. Plus 12 gives you 15. So just for a minute, you're going to times this by 15 halves, just for a second. Because that's the only way you're going to get 15, because that's an O2, right? So go ahead and put 15 halves here just for a second. Now in math, to get rid of the bottom number, we times each number through by the bottom number here. So this will become 2, 15, 6, and 12.
And then when you want to get rid of that, so we're going to remember all of them by 2. So this one.
There you go. The number, don't write ones. Just leave them blank.
Number 4, 1, especially.
Okay, so 2 and 2. This one is 6. This one should be 6 right here. It says 2 times 3 is 6.
And also 2.
Yep.
Can you check mine too? That looks right.
Okay, so that means we need 6 over here. So here's 3. So I have to put a 3 in front of here to get 6 hydrogens and to get 6 oxygens.
Because when I'm putting a 3 right
You see that? Because that would be 6, and then I go back and say, oh, I have 3 oxygens and 3 more
So I
oxygens.
don't need to.
No. Okay, which one? Okay. So when you get yours done, go ahead and put it up. Up on the board.
Wait, Miss Howe?
It's already written. All you have to do is put the balance numbers. Mhm. So 3 and 3, 3 and 3, 1, 1, 4, 4. Yep. Okay, sorry.
That's right.
2, 6, 6, 3. No. Because this has only 5 oxygens on this side, and you've got 6 on this side. So you'd have to do 5 halves here and then times through by 2. Okay. Okay, so as they put stuff up on the board, double check them, make sure that's what you're getting.
Okay, so over here too, there's one hydrogen.
1 and 1,
1 and 1. So here there's
3 and 2.
So could
So common factor is what?
I cover factor?
What do they both numbers go into? 6, right? So over here I'm going to have to times that by 2, and over here I'm going to have to times that by 3. When I do that, that changes my nitrogens.
Okay. So that would be
6, 6, and that would change that nitrogen to 2. So now you got to fix this nitrogen on this side and put a 2 in front of it.
so how do I do that?
Just put a 2 in front of it,
Okay.
and then cross that out, make it a 2. Now go to your oxygens.
So there's 2 here.
There's 2 plus 3 gives you 5. So now I'm going to have to use that little trick we used on number 1. So I'm going to have to times this one by 5 halves. Not 15 halves, just 5 halves. Because I want to get to 5, right? So I'm going to put 5 halves here just for a second. Then I'm going to go through and times all these by 2. Okay?
The N and the H are together.
That should be 4, not 10. You're timesing it just by, yeah, you're just timesing it by 2. No, 5 was right there. So then you times this one by 2,
And that's 4.
right? And then you times this one by 2, and it's, yep,
Okay.
done.
Wait, Mia, put my 2 back up for number 4, please. For number 4.
Oh.
No, I said 2.
You gotta fix your 4. Okay, so double checking. It's all good. That's the other side. All right, so looking up here, how do you feel about what's up here? Were you able to do those? Okay, I am going to put these up on the web. It'll be up on the thing. So if you didn't get through them, you can practice and see if you got them, and then get back up on them. These are done correctly, so you did a good job. Okay, so I'm just going to go to the next set, 9 through 15. I'm going to have some other people put them up, so we're just doing some practice real quick. So that doesn't mean those of you that have already had a chance aren't free game again. Okay, Valerie, number 9. Megan, number 10. Caleb, number 11. Andre, thank you. I knew I was saying it wrong. Number 12. Kylie, number 13. Jordan, number 14. And Carly, number 15. Okay, keep trying it. Keep practicing. Keep practicing.
So number 12 is going to be S-O,
OS, yeah. And then PT, then CL, then O.
B-T, C-L.
Okay, remember, always keep hydrogen, oxygen to very last. Hydrogen, oxygen to very last. Okay, as soon as you get yours balanced, go ahead and put it up.
Would this, let's see, where is it? So this would go to here, which would be 2, and then times this by
Be
that,
6.
so it'd be 6. And then I would take,
But over here you've got 3, and you've got 3.
oh shoot, so then it'd be,
And you have 6 hydrogens. So you're 6 and 6, you're done. See, you have 6
so
hydrogens,
it'd
3
just
times
be
2.
1, 1, and 2.
So no, that was right, to leave the 3 there. So 3 times 2 is 6,
Yeah.
and 3 and 3 is 6. And that's what you needed on this side to balance that side.
Okay.
Okay? All right. So there are a lot more balancing equations. Okay? I need you, I know that it's almost time, we've got about 2 minutes. I need you to practice these balancing equations because we're going to hit the road running next time, and you really need to start doing your homework. Just a sec. Learn Smarts are open, so you need to get in and do your homework so that when you get to your, sorry, let me try that again. You need to do your Learn Smart so that when you get to your homework, you have a better chance of getting a good grade. Some of you are not finishing your homework, and that's causing your grade to go down. Okay, so you need to make sure that you're doing that. On A, you have 3 chances on each problem. If you get through 2 chances on a problem and you haven't got it right, figure out what you think it is, but don't submit it and come see me. Okay? And so see if we can get you better scores. On the S, it's just one and done. So do it. If you have questions on any of them before you submit, come see me. Okay? So we can get your grades up and we can get you doing what you need to do. Yes?
Did I get 12 hours?
OS 0404 PT 22. Yes. So go ahead and put it up. Okay, who is number 15? Let's get that one up really quick, and then I'll close this video and I will put it up. Did we get 15? Anybody? I'm going to just quickly do it if you're not. Oh, there she comes. No? Okay, so 3 here and a 3 here should balance it out. Okay, I will stop this and I will put it up on the web so that you have it. We're going to probably have to do a little bit more next time to go through. I'm planning on the 2 days before Thanksgiving to do some demos and show you different types of reactions because that's what we're going to be getting into next time. And then we'll do some other stuff to cool. Okay? See you next time.